Welcome back, Algebra 1 students. We are in lesson 57. And we're going to talk about the addition of algebraic expressions with negative exponents. We learned to simplify algebraic expressions by adding like terms and to add abstract fractions by finding a common denominator. For instance, if we have a over x squared y plus b over, that's a b, x3 m2, we would be able to find a common denominator there. And we would say, well, the biggest x is x3, y is by itself, and we have an m2. That would be our common denominator, right? So then we would turn around, we would multiply this with what's missing. And we would say, okay, I'm missing an x and m squared from here. So a x m squared over x3 y m squared plus, and then what's missing from here is just the y. So we would multiply this by the y. So we'd have by over x3 y m squared. So now we have a common denominator. We could put these together. So our answer would be ax m squared plus by all over x cubed y m squared. All right, and that would be how we would solve a problem like this that we wouldn't be able to combine. It allows us to combine them and have a one fraction answer. All right, so that is what we are going to continue to do, but now we're going to do it with negative exponents. So let's find our first problem, 57.1. And here is our expression, ax negative 1 plus y negative 1. And our example instructions say to add and write the answer with all exponents positive. All right, so the easiest thing to do is to go ahead and get rid of the negatives on the front end. So we can say a over x, that gets rid of the negative 1, right? Plus, let's do 1 over y. That gets rid of the negative 1 too. Now we could find a common denominator of xy, right? That's our common denominator. So we multiply this by the y and we get ay over xy plus we multiply this by the x and we get x over xy. Now we can say ay plus x over xy. And that is our answer. So what we're doing is we're just moving them around to get rid of the negatives first, and then we are finding that common denominator and multiplying and combining. That's all we're doing, okay? Let's clear this, and let's do 57.2. And we need all exponents positive. And here is the problem. We have ay minus 1 x plus bz. All right, what I would like is for you to do this problem. So pause the video, solve this, combine this, and then this is add with all exponents positive. Combine this and come back and see if you got the correct answer. All right, if you got ax plus bzy over y, that's the correct answer. So what I did was I brought the y down to the denominator to make it a positive 1 exponent. And I put bz over 1 to make it a fraction. And then because y is really the only unique variable here, y is the common denominator. So I multiplied. I didn't have to do anything to this because y was already the denominator in this one. But I multiplied bz and 1 times y and got bz over y. Then I was able to combine them and just say ax plus bzy, put it all over y, we were done. Easy peasy. Let's clear this and do 57.3. And we have a negative 2, xy negative 1 plus az negative 1. So first things first, let's turn everything into a positive integer, or I'm sorry, not a positive integer, a positive exponent. And we could do that just by taking it to the denominator. So x is positive, so we leave it up top. A is negative, so we take it to the bottom, make it a positive. Y is negative, so we take it to the bottom, make it positive. All right, that's that one. So now we have a z to the negative 1. Well, a is positive, it stays, and we move z, so it becomes positive. Now we have to find a common denominator. Well, if we just multiply the two together, that becomes our common denominator. So a squared yz is our common denominator. So now we just need to multiply. So the only thing missing here from our common denominator is the z. So we multiply this whole fraction by z and we get xz over a squared yz plus, now we need the a squared y on this one, so we multiply. And when we multiply a squared times the a, we get a cubed y and then a squared yz on the bottom. Now we put them together, xz plus a3y all over a2yz. All right, that is our answer for this one. Let me double check. And that is correct. That's what we have. That is the entire lesson, my dears, for 57. That is all I have for you. So I will see you in lesson 58. If you have any struggles with this, please text me or message me, and I will help you. And I will see you in lesson 58.